Is at the Hagley Library. She's doing some experimenting of her own this morning. So, Sophia, what are you mixing up for us today?
Good morning, guys. So here at the Hagley Museum, they have something called Science Saturdays twice a month, and it kicks off February 22nd. And within that, there's something called Chemistry for the Curious, and it's hosted by Dr. Mike Staminsky. Good morning, Dr. Mike.
Good morning.
So your segment starts, is it March 7th?
March 7th.
March
yes.
7th. Okay. So tell me a little bit about yourself and what we're going to get into today.
Okay, we're going to do some decomposition. This is going to be a decomposition reaction.
Okay.
I have some hydrogen peroxide, and I'm going to take some dishwashing liquid.
All right.
And put it into this graduated cylinder that has the hydrogen peroxide in it.
Okay.
And we're then going to swirl it around a little bit to make it a nice homogeneous mixture.
Nice.
Then I'm going to take a few grams of this compound called potassium iodide.
All right.
And we're going to put it into that cylinder and see what happens.
Oof. Let me step back. Oh, wow. Woo! Oh, that's fun. So what is the chemical reaction happening here?
Okay, this is a decomposition reaction, and so the hydrogen peroxide was decomposed by the potassium iodide.
Cool.
And this is foam, really, from the dishwashing liquid. And we like to call it elephant toothpaste.
I get it. I get it. And it keeps happening.
It keeps on going until the reaction's done.
All right,
okay, now over here, I have a graduated cylinder, and I'm going to put a mixture of dyes called a universal indicator into the bottom of this graduated cylinder.
Okay. This is dyes.
It's a mixture of dyes. Okay. It's called a universal indicator.
Universal indicator.
Now, I have in this container ammonia solution.
Okay.
And so I'm going to put a few milliliters of ammonia solution into this beaker, which is plain ordinary water.
Gotcha.
Now, you can see that it's colorless.
Yeah, colorless.
But we're going to pour this into the graduated cylinder.
Oh, it's purple. Very cool.
And it is a purple color.
Right.
Now, the reason it's a purple color is because ammonia is basic or alkaline, and the mixture of dyes that I have here indicate with this color that it's alkaline.
Okay.
Now,
so purple
here's the fun part. I'm going to take some dry ice.
Okay.
And I'm going to drop the dry ice into the graduated cylinder. Now,
wow.
What's happening is that you're going to see a color change taking place because the dry ice reacts with water and it makes an acid, and then it's going to be neutralizing the ammonia and lowering the pH, and the mixture of dyes that you see in there changes color with the changing pH.
Awesome. This is so interesting.
And then now eventually...
Oh, wow, it's changing again.
And that's where it ends up. And so therefore, we have here what is called an acid-base reaction, and we can follow it by the colors of the universal indicators.
Wonderful. Dr. Mike, thank you so much.
You're
you can check him
welcome.
out March 7th here at the Hagley Museum. And for more information, you go to hagley.org to see when these Science Saturdays are offered. And Nick Kelsey, back to you guys.
That was very cool.
Very interactive. I love it. Yeah, exactly. Thank you, Sophia. Let's check in now.